The half-life formula is a formula that describes how much of a substance or how much of an element is left after it has decayed for a certain amount of time. So here's the formula. N, where N is the remaining quantity of substance, is equal to N sub 0, where N sub 0 is the initial quantity, times 1/2 to the power of T divided by T half, where T is the total time that has elapsed, and T half is the time that it takes to cut the quantity in half, or sometimes this is called the half-life of the substance. So let's check out a couple examples of how to use this formula. Let's say we're told that a substance has a half-life of 30 years. If 10 grams of this substance disintegrates over the course of 90 years, how many grams would remain? So to figure this out, let's fill in everything that we know in this half-life formula. So we'll say N, remember N is the remaining quantity, that's what we're trying to figure out. That's equal to the initial quantity, which we're told is 10 grams, so we'll say 10 times 1/2 to the power of T, where T is the total time that elapses. So we're told that we're going to use 90 years, so 90 divided by T half, which is the half-life of the substance, and we're told that's 30 years, so we'll say 90 divided by 30. So how can we solve for N? Well, we can start in the exponent up here. 90 divided by 30, that's just equal to 3. So what we really have is 10 times 1/2 to the power of 3. To figure out what that is, we can just do the numerator to the power of 3 divided by the denominator to the power of 3. So we could write 1 to the power of 3 over 2 to the power of 3. Well, 1 to anything is just 1, and then 2 to the power of 3, that's 2 times 2 times 2, that's 8. So what we really have is 10 times 1/8, that's just 10 over 8. And if we wanted to write that as a mixed fraction, we could just say 1 and 2/8, or 1 and 1/4. Or if we'd like to write it as a decimal, we could say 1.25. So that's our final answer. There will be 1.25, and remember the units we're working with are grams. Say that there will be 1.25 grams left of this substance after 90 years. Okay, let's try one more example. Let's say the half-life of a substance is 2 years. How many years would it take 16 grams of this substance to decay and only have 0.5 grams left? So let's fill in what we know for this half-life formula. So N, the remaining quantity, in this case, we're told we want to have 0.5 grams left. So we can write 0.5 is equal to N sub 0, that's the initial quantity. We're told that the initial quantity is 16 grams. So we'll say 16 times 1/2 to the power of T, the total time elapsed. We don't know this. This is what we're actually trying to figure out, T, divided by T half, or the half-life, which we're told is 2 years. So we'll say T divided by 2. So this problem's a little bit different. We're actually trying to figure out what is T. So what is the total time that would have to elapse for us to get 0.5 grams left? So we're solving for T. So to do that, the first thing we can do is divide both sides by 16, just to get rid of this 16 out front. So on this right-hand side, these 16s would cancel out. If you punch in 0.5 divided by 16 into a calculator, you get 0.03125. So that will be equal to 1/2 to the power of T divided by 2. Now, when we have 1/2 raised to this exponent right here, we can get rid of the 1/2 by taking the log of each side. So we can write the log with a base of 1/2 of 0.03125 is equal to the log base 1/2 of 1/2 to the power of T divided by 2. So when we do this, this whole expression right here cancels out. So we're just left with, I'll make a little room over here. We're left with log base 1/2 of 0.03125 is equal to T divided by 2. So to solve for T, we just need to multiply both sides by 2. So we'll be left with 2 times the log base 1/2 of 0.03125 is equal to T. Now, some calculators or some software that you use might be able to use the log of base 1/2, but some aren't able to do this. So one thing that you can do is you can use something known as the change of base formula. And I'll link to another video that I have on that. But this formula says if you have the log base b of a, you can rewrite this as the log base c of a over the log base c of b, where c is just any number that you'd like to use for the base. So a common choice is log base 10. So what we can really write, we can rewrite this as 2 times the log base 10 of 0.03125 divided by log base 10 of 1/2, or we can just write 0.5, and that's equal to t. So when you type in the log base 10 of 0.03125 divided by log base 10 of 0.5, this actually turns out to be exactly 5. So our final answer is 2 times 5, which is 10. So 10, remember we're talking about years. So we'll say 10 years is equal to t. So it will take 10 years for this substance to decay and only have 0.5 grams left. So those were just 2 examples of how to use the half-life formula in different scenarios.